All right. Hello, everyone. Welcome to this trench rescue introduction or refresher. For most of you, it'll be a refresher course. Some of you may be getting this information for the very first time. The information in this slideshow is kept very simple. It's that fundamental knowledge that you may have received in the classroom during your trench introductory course and have since not paid a lot of attention to or perhaps forgotten. Just a little bit about myself. I started with West Jordan in 1998. Been with them the entire time, full time. It's been wonderful. Got my introduction to trench rescue in 2006. It was a great course. I fell in love with it. The department asked me to put together at that time a book on trench rescue, and that kind of prompted further study on my part, research, looking at other departments, seeing what they do, looking at other departments outside of the state, looking at national trends, looking at OSHA documents, various studies that have been done on trench rescue. Started talking with soil engineers, trying to just really digest and understand the full scope of trench rescue and what I was trying to do. Bit of a disclaimer, so if you've never had a trench course from a qualified instructor, please don't watch this slideshow or any of the elements on this YouTube channel and go out and start jumping into trenches. You need to have the instruction of a personal, on-site, live, qualified instructor who can look at you and guide you through things appropriately. Everything on this YouTube channel is simply a review for professionals who are already qualified. Again, this course material is fairly simple, covering just the basics. You'll get the most out of this presentation if you're taking this slideshow, listening to it in the midst of other trench technicians. There may be differences in terminology, different from what I use and what your department uses. As a teaching medium, this medium is great because you can watch this slideshow on your own, at your own pace. It's readily available to you very easily. However, it's also difficult as an instructor to use this medium where you can't see my body language and you can't see mine. So please, if you're a person in the room, perhaps you're watching this with your crew, if you're the person in the room who has qualified trench training and everyone else in the room has a quizzical look, maybe I said something and they're confused, pause this slideshow and talk about it. Use it as a springboard for some discussion. Also, make sure that this slideshow, if you're viewing it as a group, is on a large TV where everyone can see. You're not all huddled around a tiny laptop. Alright, so why is trench rescue important? Trench rescue calls do happen. It happens every year. On average, trench rescue, or I should say trench incidents, are occurring at a rate where the fatality rate right now is somewhere between 50 and 100 per year. The average death age of individuals who are victims of trench collapse is the early 20s. Sometimes where there's multiple victims involved, they're usually father and son. When trench calls do come in, they're very high profile. It's one of those skills, just like many heavy rescue skills. It's a very high profile thing. Gets a lot of media attention. With trench rescue, due to the patient's ages, very salvageable patients potentially. They're young, they're healthy, they were working in a career mode where they're doing physical work, so they're normally healthy. We can save these patients with the correct training and with a bit of luck. Of course, in trench rescue, you can't save all of them. In fact, most will be fatalities. But try not to take the attitude that all trench rescue is just body recoveries. There are a lot of times when, if you watch the media and watch the news, research it every year for you kind of do an annual assessment of trench calls throughout the nation, you'll see that there's actually quite a few times where individuals are significantly buried and are actually pulled out alive. Trenches themselves are present all over the place continually. Look around with our infrastructure nowadays. Construction companies are always needing to dig trenches, whether they're installing new facilities or going back and repairing or replacing old utilities. Trenches are common. They're common everywhere. And as is the case with all human nature, there's always room for complacency. There's always a tendency to try and skip the rules, and creates that potential for hazard. So at the completion of this slideshow, you should have a solid foundation of the knowledge that is involved and related to trench rescue. It's not a complete comprehensive course. You normally would take this course in conjunction with live instruction. You would see the slideshow, talk about the principles, and then go out and do it. We teach so much more and offer so much more information when we are on site and can look at the tools and show and tell you. But just watching this slideshow will give you a good review. Trench rescue is incredibly dynamic. The fundamentals are there and present on every trench collapse, and yet each trench situation has the potential to provide and challenge you with so many different elements. It can be a large trench, small, utilities involved, the collapses are occurring in different ways, different levels of injury, the soil principles themselves, the soil differs from place to place. So trench rescue is great in that way, where of course those fundamental principles are the same for every trench, and yet every trench is going to be completely different. Because normally when we complete the slideshow, we go out and do these skills. Obviously, it's always prudent to mention safety. Anytime you're doing live trench training, it's very dangerous. There's always potential there. If it's a live trench, just because you're doing training, that danger is not eliminated. It's very present. As instructors, we try to view the trench, look at it, look for danger signs, and make sure that it appears to be stable as possible, and that we feel confident in training in it. However, we still take the same precautions that we would with a full trench rescue. No one's going to put a ladder in the trench and get down there just to play the victim role. We're always going to use mannequins, and as we go in to retrieve them, we're going to be doing all the things that we would do in a normal trench rescue. Of course, everyone is responsible for safety. If and when you do go out to perform these trench rescue skills, make sure everyone has their head on a swivel and is looking around, making sure to observe for safety issues. At any time anyone sees an issue, of course, you can yell stop, 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 or bring attention to the situation to make sure it doesn't become an accident or an injury or a death. Most likely it's going to be summer when you go out and do live trench training, so please do make sure you stay hydrated and you're in a good condition to do the training. I have broken this training up into modules, like I said, so please, at the end of each module, please feel free to pause, shake it out a little bit. If you have a heavy rescue available to you or trench equipment available to you, please go out, view it, talk about it with your crew members who understand it and know it. Make the training as interactive as possible. Alright, so your learning objectives. Basically, at the end of this module on base principles, by the end of the module, you'll fully understand the danger of trench rescue, why soil is dangerous, where you can find some of the governing information regarding trench rescue. I should say probably trench in general, right? It's going to be OSHA, of course, as well as understanding the concepts of providing stabilization to the soil and how that reduces the danger. Let's look at just a few definitions here. Of course, an excavation is any man-made cut, cavity, trench, or depression in the earthen surface formed by removing earth. A trench is always an excavation. However, an excavation is not always a trench. So what is a trench then? A trench is any excavation in the ground that is deeper than it is wide, no wider than 15 feet at its bottom. When wider than 15 feet, we kind of go back to it just being a large-scale excavation. Now, when we talk about trenches being deeper than they are wide, they need to be at least 4 feet deep to require that some form of trench protection be used. However, a 3 foot by 1 foot trench is still, a trench. It just doesn't require trench protection. So when we talk about trench regulation then, when is protection required, really what we're talking about, of course, is OSHA. It's largely a construction industry mandate. Of course, if you go back far enough in history, you get to a point where OSHA wasn't around, and continue to go back further, you get to a point where really we didn't have trenches. But at a certain point, of course, as a society, as a country, we figured out, we need better utilities. We need more than an outhouse and a lantern, to provide our light. So over time, of course, as technology developed, we start digging deeper and deeper trenches to provide, better and better water, electricity, those kind of things. So trench rescue or trench becomes a dangerous work environment. OSHA comes into play, is created. Right around 1980, OSHA did a study and found that regarding trenches, there's like a 112% greater fatality rate versus the other forms of injury related to other construction. Of course, that raises a ton of eyebrows. You have a lost time to fatality ratio of 250 to 1 for the rest of the industry. Well, of course, OSHA realized that we need to implement a set of regulations for trenches and get that to be a safer work environment for people. If you want to actually look at the OSHA information and the regulations on trench safety, you'll find that in 29 CFR part number 1926 subpart P. So that's available to you to go and look at if you so desire. It's actually fairly simple and informational. Again, it sets kind of a construction industry standard, but even as rescuers, we should be familiar with it and know it. Of course, when you talk NFPA standards, 1670 is the standard on operations and training for technical rescue, and 1006 is the standard for rescue technician professional qualifications. Alright, so let's talk some basic soil principles. Of course, uncut soil is very passive. Soil itself has a natural kinematic energy to it. When it's uncut and just there, not a lot of potential for movement. There is some, but not a lot of potential. In this state, you can, if you want to relate it to paramedic type phrasing, you can say that this soil has homeostasis. Okay, it's very passive. It's not going anywhere. Of course, as soon as we excavate, As soon as we create a trench, we now have taken that very passive, low-grade kinematic energy, and now we've made it very active. We've given it a high potential for energy. The gravity is acting on it. The environment is acting on it. There's all these things. Vibration in the soil, hydrostatic pressures via rain or other things, environmental factors like wind. And of course, just given over time, the longer it's open, the freestanding time of the trench, the longer it's open, the cohesiveness of the soil breaks down, and eventually it will collapse. Now, the danger of trench and excavation activity essentially comes from soil's weight in combination with its propensity to move. So, when you think of the typical capacity of most backhoe loader front buckets being 1 cubic yard, if you've done any amount of landscaping work, you'll know that 1 cubic yard or a front bucket is not a lot of soil. However, it is a lot of weight. The accepted general weight of soil, just like a rule of thumb, would be 100 pounds per cubic foot. That kind of simplifies the calculation and makes it nice and easy. However, it's a low estimate. According to the OSHA Technical Manual, soil's weight is actually, depending on water content, rock content, going to be more close to between 110 pounds to 140 pounds per cubic foot. So when you think of it that way, suddenly now you have a front bucket that weighs, the weight of a mid-sized automobile, somewhere between 2,700 and 3,500 pounds. Consider that now coming in on top of you, if you were the one in the trench. Yeah, it's a very dangerous situation. OSHA Technical Manual states that 1 cubic meter, 35.3 cubic feet, is going to weigh possibly, again, depending on that rock content and water content, more than 3,500 pounds. A single trench collapse can very easily involve 3 to 6 cubic yards of soil. So, we really are dealing with a very large amount of weight, a very large amount of potential energy here that creates that danger and hazard. That's the reason why, if you show up on a trench, whether it's collapsed or not, if the trench is unprotected and somebody's down in there, maybe they're just unconscious, they've had a medical problem, a heart attack down there, if the trench is unprotected, you do not want to enter that trench. Looking and considering those soil weights, you will not survive if you are fully buried. Unless perhaps you get lucky. There are circumstances that create those situations where even fully buried persons or victims survive. There was a pipe between them and most of the collapse, or they were able to duck into a pipe, or the collapse happened in such a manner that they had a pocket where they were. So complete burial isn't necessarily the full end-all be-all, but you are dealing with large amount of weight. Now, the weight of soil can be compounded by surcharge loading. When we talk surcharge loading, we need to talk encumbrances. An encumbrance is any additional weight masses on the soil surface. It can also be, you can have subsurface encumbrances. So anything on top of the soil nearby to the trench is going to apply additional weight to the soil and to that wall, creating that a greater chance of energy. Surface encumbrance might be improperly placed soil, like a spoil pile, heavy machinery, any kind of buildings, walls, any other equipment on the soil surface. Where a subsurface encumbrance is going to be any kind of piping or utilities that are underground, water tables, streams nearby, transformer vaults, those kind of things. In the diagram here, or the graphic you see, Y is representing our encumbrance. So surcharge loading then is any excessive load or energy created in the soil by the encumbrance, causing an increase in vertical load or weight. So that just adds to that weight of soil. It's pushing down, it's exerting its own weight, and we have even more potential for collapse. And when that collapse occurs, it's going to occur involving higher weight. You have your weight of soil plus whatever the encumbrance is contributing. If your trench is 10 feet deep, general rule of thumb is anything within 10 feet of the trench's edge is specifically adding additional potential energy to the exposed trench wall. So then the basic principle behind bringing stability back to a trench involves this. So we have soil that was nice and stable. An excavation occurred, creating the trench and giving all this potential energy to the soil. So when we arrive, given an open trench, we will put in means by which to put pressure back into the soil, balance out the pressures that are trying to come in, and restore homeostasis to that soil. When we use trench boards and cross braces, our struts, we're pushing pressure out, and hopefully we're doing it in a manner where our pressures from one strut to the next are overlapping, and it creates a nice solid pressure that best simulates the homeostasis that was there previously. This is really due to the arcing principle of soil pressures. So as we push on the soil with our struts, we're exerting a pressure that goes outward and expands. So as soil is pushing in, you kind of create, when you have we'll talk about the rule of fours later, but when done properly, our struts are putting pressure into the soil, and it creates, for sake of explanation, like a archway, like a architecture archway, where as pressure is coming in, even toward the soil that's between the struts, that pressure then is absorbed and redistributed out towards where those struts are. Now, this arcing soil principle occurs both on a vertical plane as well as on the horizontal plane. So, in some circumstances, like when we go and do trench rescue, we'll apply that rule of fours on a vertical and horizontal plane. Now, in some instances, you'll see in the construction industry per se, so they'll use like spaced shoring. They can do this in part due to the arcing soil principle. That arcing soil principle allows, with say like a type A or type B soil, in some instances to not need the sheeting. You see in the diagram there, and we'll talk a little bit more about it later, but that's an example of open spaced shoring. When we do this as a form of trench rescue, of course, we apply it as closed shoring. We'll create this arcing principle both vertically and horizontally, and we'll do it to create an area that's at least 12 feet wide when conditions allow. So going back a slide or two, you can see, with these cones of pressure, with the struts in the right locations, those strut pressures overlap one another. If we weren't obeying the rule of fours and we had, say, some struts that were 7 feet apart, very hard to get pressures that are going to work well enough to have these cones of pressures extend out to that distance. At the 4-foot marker, when we apply our pressures correctly, 200 or 250 psi, depending on what strut you're using, you'll get that correct overlap of the pressure cones, and you'll be utilizing that arcing soil principle to the best advantage. So trench rescue then really is all about restoring homeostasis to a soil that was previously passive and has now become active and unstable and unsafe. Okay, so that's really the end of this module. Not too painful, short and simple, pretty basic, basic fundamental understanding, right? At this point, you should be able to state the parameters that define an excavation as a trench. Should be able to answer what is the primary document where regulations on trench safety can be found. And at what depth are trench protective measures required? Of course, you can read that final question there. Think about those soil weights, see if you can answer those questions. If you can't answer any of these questions, please go back and review. Then finally, can you just generally state the principles by which rescuers render open trenches safe? Great time to pause the slideshow, take a break, go shake it out, talk amongst your other trench technicians and see if you have anything to add. Alright guys, getting into Module 2. So, hopefully you slept at a Holiday Inn last night and you're feeling fresh. Grab some coffee and buckle in. Okay, put your reclining chairs in the upright position. And here we go. So OSHA Regulation 29, Code of Federal Regulations there, put soil classifications in 1926 Subpart P and Appendix A and states that technical rescuers must be able to readily identify what soil they are dealing with so that they can anticipate problems with the rescue plan. Considering that, here's some of our objectives. At the end of this module, you'll be able to state the 4 primary soil types and describe the tons per square foot rating for each. You'll be able to describe the methods of mechanical and manual soil testing. You'll be able to describe the various parts of a trench. And you'll be familiar with the phases of soil movement leading up to collapse and the mechanisms by which collapse occurs. Also, you'll be able to name and describe the types of collapse, describe the different protective methods used in the construction industry to make trenches safe, as well as be able to specifically state the component parts of a shoring system. Alright, working right out of the OSHA Technical Manual here. You'll hear me refer to that as the OTM. So the unconfirmed compressive strength of soil is the load per unit area at which soil will fail in compression. And that's kind of what they base their soil types on. So we have soiled, wow, okay. So we have solid rock, which, pretty simple, right? Pretty basic. And for solid rock, they don't actually give it a tons per square footage rating for the unconfirmed compressive. Holy cow! Give me some water. So they don't give solid rock a unconfirmed compressive strength. Okay, for the remainder of the soil types, they do. So a type A would be a cohesive soil. Now, they define a cohesive soil as a clay with cohesive strength, where the particles want to stay together. Okay, so type A is a cohesive soil with a unconfirmed compressive strength of 1.5 tons per square foot or greater. So that's really what you need to know. Type A is cohesive with a rating of 1.5 tons per square foot or greater. A common test question, of course, when taking your trench exam. The caveat with type A soils is that no soil could be classified as type A if it is fissured, subject to vibration, previously disturbed, or sloped greater than 4 horizontal and 1 vertical. For our part, as rescuers, when we come on scene of a trench collapse, right, you can anticipate we're not going to be dealing with type A soils, generally speaking. Now, it is possible for a type A soil to collapse, hence its 1.5 tons per square foot rating. It just takes a large amount of weight and various factors to get that soil to lose its cohesiveness. Now, a type B soil is a cohesive soil also, but it has an unconfirmed compressive strength, or a UCS, of 0.5 tons per square foot or up to 1.5 tons per square foot. So between that range, 0.5 to 1.5 for a type B soil. Type A, 1.5 or greater. Type B, 0.5 up to 1.5. With the type C soil, you're going to have 0.5 or less. Now, any soil where it's submerged, if there's water freely leaking from the walls, or even submerged unstable rock, will just automatically receive this classification. There is an additional soil type, a C60, but that's that's a topic for another slideshow. For anyone who's really excited about soil types. Okay, so how do we get our our soil rating when we arrive on scene? Well, we're likely not going to be classifying things obviously in tons per square footage failure rating. However, there are manual soil testing that that you can do. One of those manual soil tests is a plasticity test or a thread test. You're going to take moist soil, probably from the spoil pile or wherever it's available. You may need to get some soil wet in order to do this test. You're going to take it, get it into your hand, and roll it up like a ball. You remember Play-Doh? Roll it into a ball, and then you try to roll it into a thread as thin as 1/8 inch in diameter. If you can't roll it into a ball at all, then you know already the soil is not cohesive. If it's not cohesive at all, you can classify it as a type C. Now, if you can get it rolled into a ball, then roll it into that thread. And if by the end of the thread you can hold that thread and it doesn't fall apart, then you have a soil that has some cohesiveness to it. So likely this will be a type B or type A soil. Of course, again, type A has all those caveats. So at best, you're dealing with a type B, and still potentially even a type C. Type C is still considered a cohesive soil. Type C is just the least cohesive of the group. Another form of manual test is the dry strength test. So here you're going to pick up a dry piece of soil, hold it in your hand. If it crumbles on its own, certainly you have a fairly low amount of cohesion. or as you take this chunk in your hand and you use your thumb, so that chunk sits in the palm of your hand, you use your thumb, start to put pressure on it, roll it around. If it begins to break down at that point, then again, you've identified that it has a low cohesion. Okay, so if it starts to break apart, then it's going to be considered granular. If it's dry and falls into clumps that break into smaller clumps and it just continues to break down, then we know we're dealing with low cohesion. If those smaller clumps can be broken down only with great difficulty, then it may be clay in combination with gravel, sand, or silt. So, with any of these manual tests, is it very foolproof? No. Is it highly subjective? Yes. You might pick up one dry piece of soil and begin to test, and it falls right apart into bits, and walk 10 more feet over and pick up another piece and have a hard time getting it to break down. So with all this manual soil testing, it is very subjective, and it's just a tool for you to use. Certainly, OSHA says you need to know it, so be familiar with those forms of testing. There is another form of manual test called the ribbon test. With the ribbon test, it's done to determine how much clay or silt a soil contains. So you're essentially going to take a saturated soil, begin to roll a 3/4 thick 6-inch long cylinder, lay it across your palm. Okay, try to keep your mind on soil. Okay, so the cylinder laid across your palm, then you begin to squeeze and push some of that soil out over your thumb and forefinger until it's approximately 1/8 inch thick. Now, as this is done, and you just allow it to hang over the side of the hand, and if this piece that you're pushing over your hand, is going to be called a ribbon. And the more of these ribbons that you can get over the edge of your hand, that it stays before breaking and falling away, then this tells us how much clay may be involved in this soil. If a cylinder forms 6 or more ribbons in length, then it is said to be clay. If it forms shorter broken ribbons, then the soil contains silt, and a clay loam will barely form a ribbon of any length. If you want to read the definitions of clay loam and all that good stuff, there's plenty of it available. Look in your OSHA technical manual and it'll give you all those definitions. Probably the most practical of the manual soil testing methods is the thumb penetration test. And this is probably the one I would recommend. If you're going to do a soil test, this is a good one to do, because it actually has kind of a measure by which you say, okay, this is a type A, or this is a type B, or this is a type C. Still, it's subjective. Okay, it roughly determines your unconfirmed compressive strength. Take a recently excavated sample, okay, something from your spoil pile perhaps, or you may even try this in the side of the trench wall, just as you go down a ladder, perhaps just not descending any lower than waist height, but go down a ladder where you can push your thumb into the soil, okay, or grab something from the spoil pile. Hold the sample in one hand, and with your other hand, push your thumb into the sample. Now, a type A soil is going to accept an indent only with great effort. So you're going to be really pushing, you're going to be blanching your thumb, you're going to tell that you're having to push and force to try and get this indentation. With a type C soil, your thumb's going to easily penetrate that sample by several inches. Now, if you fall between there, your thumb readily penetrates the soil, but only an inch or inch and a half. Then you can go, okay, I got an inch and a half in pretty easy, and then I couldn't get any further. It became difficult. I'm dealing with now a type B soil. A few pictures. Your plasticity test here, your dry strength test, your thumb penetration test. and then your ribbon test over there on the bottom right. And I'll leave the comments for you guys. With the exception of some of those very first pictures you saw in the slideshow, all the pictures here in the slideshow were taken by myself, and the illustrations as well, as basic and simple as they are. Now you can do mechanical soil test. With a mechanical soil test, you'll actually get a nice reading that you can clearly say, this soil is type such and such, or the unconfirmed compressive strength is this. Of course, again, it's that rating from the soil where you pushed the testing device into. So again, it's subjective. You might measure it in one location and get this reading, and go to the opposite end of the trench and get a completely different reading, or use a different sample. So you have a pocket pintrometer, little spring operated device that when you push it into the soil, it has a spring, and it pushes in, and it'll ultimately give you a little reading. Fairly inexpensive tool. There's also a shear vane. I have not used one of these. I don't know a whole lot about it. That is another option for mechanical soil testing. Largely the soil testing and the soil types are for testing purposes, knowledge purposes. Yes, OSHA says you should know it, and it's good to know. It's good to know what soil you're dealing with, and if it's cohesive or if it's not. Of course, in the trench rescue environment, when we arrive on scene, we're going to treat it whether it presents to us as cohesive or not. We're going to handle it and address it as if it's not cohesive and it's very likely to collapse. We know through multiple studies that once a trench collapses, it's going to continue to collapse. There are going to be second collapses, thirds, and fourths. It's possible that by the time we arrived, it's collapsed several times, and the soil's in a state now where it's kind of assumed a more balanced out condition. However, we're going to operate, if we're doing a trench rescue, we're operating as if it's very unstable. Again, most of this falls back to the construction industry, but OSHA does specifically state that technical rescuers need to have a knowledge of this. Okay, again, back to your definition of a trench, just to reiterate. Okay, it's deeper than it is wide, no wider than 15 feet at the bottom. When a trench is less than 4 feet deep, it's really up to your competent person on site to apply a protective measure or not. Of course, he'll make that decision based on soil type and the conditions of the environment and the dangers present within the trench. Kind of a unique situation, just to be mindful of. If you have an excavation that's wider than 15 feet at its bottom, and yet there's some kind of form placed into the trench, whether it be a trench shielding system, or perhaps it was an excavation nice and wider than 15 feet originally, but now they've built in a foundation and elements of construction. Anything that's been put into that excavation that now suddenly has decreased the width between whatever's been put into the excavation and a soil wall, you can still then fit in that description of a trench. So, if you look at the picture here, they have a trench form that's been placed into an excavation, and at one point they looked and decided that they had enough space between the trench form and the excavation that they had dug, that they've gone back now and filled it back in with soil. So they didn't have kind of a trench created within their excavation. You can see they've done that kind of down the line. Anywhere where they had space between the trench shield and the open excavation wall, they filled that in so they don't have an unprotected trench kind of artificially created by the form. So let's get into the anatomy of a trench. It's very simple. So we're going to start at the floor of the trench. The floor of the trench is just that. It's called the floor of the trench. This is where your boots are going to get muddy. This is where a patient potentially is if he's buried underneath a bunch of soil. Okay, this is what you're going to walk on. Then you have your toe. Your toe begins at that junction point where your horizontal surface of the floor meets the vertical surface now of a trench wall. And that toe extends 2 feet up from the floor. Then you have your belly. The belly is everything between the toe and the lip, and we'll get to the lip here in a sec. But the belly, the thing you need to know about the belly of the trench is that is the area of the trench that is the most prone to giving way to the various factors that will create the collapse and give in. Whether it's gravity just over time, vibrations, hydrostatic pressures, any of those things, it's the belly area that is going to get weakened first, typically, and come into the trench. The toe itself gets a little bit of support from the floor and the soil underneath it. So, if you go back to that diagram of the 1 foot by 1 foot by 8 foot column of soil, at its very base, of course it's exerting, say we're 8 feet tall, it's exerting 800 pounds down if we're using our rule of thumb calculation. But it's also exerting pressures outward instead of directly down, and that's where it gets some support from the floor area. The belly really is not getting any further support from soil to the side of it, so that support has diminished by the time you're 2 feet up. It's gone, and now that soil can come in to that direction. So from the belly up is really the weakest area of the trench. The lip is that part of the trench that extends when you go from the trench edge. Now the trench edge is a part in and of itself. That edge is the point where the vertical face meets the horizontal surface of the soil. That area where you're going to be walking on, where everybody's going to be, say, topside. So that's the trench edge. The lip is 2 feet down and backwards from the edge. This can collapse on its own on occasion. Your bigger collapses, the kind of collapses that you get called on, are going to be collapses most likely involving the belly. Okay, so here is a video. I'll just let you watch it. This video is available separately from this slideshow. It should be on the YouTube channel just as a standalone video that you can come back to and easily reference. This is on the phases of collapse. What you're going to see is those conditions that lead up to and signify, perhaps call it a warning sign of impending collapse. Okay, this is your video on the phases of collapse. A little bit different than the actual forms of collapse. These are some of the things that happen leading up to a collapse occurring. So first, you're going to have tension. Anytime you open up soil, you're going to create a change in that homeostasis. It's going to result in tension. Gravity's acting on the soil, trying to make some changes. As the moisture level changes because drying out or rain, you're going to get tension that way. You're going to weaken the cohesion. Tension eventually results in cracks in the soil, either on the surface or below grade. According to the OSHA technical manual, tension cracks usually form at a horizontal distance of 0.5 to 0.75 times the depth of the trench, measured from the top of the vertical face of the trench. So here you're just watching me kind of illustrate the effect of the tension cracking. The next phase, so that's tension, that's the first phase. The next phase is movement. With movement, deformations in soil from increasingly imbalanced pressures start to actually change the soil physically to the point where it becomes visible. Now it's fairly minimal, most likely not going to be observed by your average construction person. Okay, here as I'm illustrating, I've made it a little bit easier to identify, obviously. So one of the things that's going to happen is the soil surface is going to change level. That's called subsidence. Okay, this is when the soil fairly close to the trench opening will actually sink. Now that can occur with or without bulging. It can just compress and sink where you really don't have a bulge, but a lot of times you're going to also get bulging. Bulging is another form of movement that indicates collapse. It's one of those things you want to look for if you're teaching a trench class or working around a trench. You want to observe the trench walls for subsidence and bulging. If there hasn't been a collapse, those are signs that a collapse is impending. Okay. There is another form of movement. And that movement is called bottom heaving. In bottom heaving, pushing up of the soil at the trench floor results from all that significant pressure pushing down. The trench floor is weakened more so than the trench walls in this case, by moisture or by some other means. It might just be inherently weak at that level of depth, and it pushes up. Some experts classify this condition as a form of collapse known as compression collapse. Okay. Another form of movement is boiling. Here we're still watching the bottom heaving. Figure the illustration would be a little bit better than just a dry slideshow. So another form of movement is boiling. Boiling happens when the trench has been cut, for the most part, into a water table, and maybe there wasn't water in there initially, but over time the water seeps in, begins to push up the trench floor, as well as create a saturated condition down there. Of course, when that happens, you're weakening the support of the trench walls, and it's an impending warning sign of collapse. Now the third phase leading up to collapse is actually collapse. So this is more the means of collapse more than a phase leading up to. But you basically have two means by which collapse is going to occur. So either the collapse will occur gradually or it's going to occur catastrophically. But it's either going to occur because of toppling. Toppling occurs when the trench's vertical face shears along the tension crack line and topples into the excavation. Now, more accurately, toppling is a forward rotation out of the slope of a mass of soil and rock, also about a point of axis. So here, I've put the red dot into my illustration here. Kind of showing how the collapse, and it could be, that point could be at anywhere in the trench wall. It could be at the very base where the floor meets the toe. Typically, the belly of the trench is the weaker area of the trench. So here I threw that dot there just to kind of show you. So here, the toe is staying strong, but it's pivoting from that weak point in the wall, and it all kind of moves on that. It kind of acts as a point of axis for the collapse. You can see how gravity just takes it. So another form is called sliding or sloughing. That's commonly here. It can be a little bit confusing because there is a type of collapse with the same name. However, as a means of collapse, this is just where it's a downsloping movement of the soil. The cohesion is weakened, and different from a pivot point or an axis point where it kind of topples in. You can kind of think of this as like when the soil, when you have a spoil pile, the soil will try to attain that nice desired angular slope, that angular repose. Here the soil, as cohesion breaks down, the soil is sliding down into the trench. Again, can be catastrophic, or it can occur, gradually. Factors that contribute to soil collapse include, soil activity, vibration, hydrostatic pressure, environmental factors, the amount of freestanding time. All those things are going to play a part. Soil activity includes the soil's kinematic propensity for movement. It wants to go. Gravity's working on it. Time is all it needs. Eventually, at some point, any open trench is going to collapse. If left continually subject to environmental factors, gravity, hydrostatic pressures. All right, so here we have just a review. You have your tension cracking. Your first forms of movement, subsidence and bulging. That bottom heaving. Boiling. Of course, your toppling, pivoting on that axis. And then again, you have your sliding and sloughing. All right. Well, this has been Jason Hinkins again with the Trench Review. This is the phases of collapse. Please don't confuse them with the types of collapse, shear wall collapse, etc. We'll make another video for that. Hope you enjoyed the little bit of illustration. All right, so you can't go out and really film those phases of collapse. Also, you can't go out and really film the types of collapse as they occur. So. They are different though. So here we get into the types of collapse. So your primary types of collapse will be spoil pile, slough in, or slough in, depending on how you say it. Shear wall, there's complete and partial forms, lip failure, and toe failure. So, OSHA requires a 2-foot setback for spoil piles. Spoil piles are an encumbrance. They add soil weight. They contribute to that surcharge loading. They contribute to surcharge loading. And, just by virtue of being next to the trench, they can be enough to contribute and cause a collapse to occur. At the same time, they're sitting there. They have a natural angle at which the soil wants to settle, that maximum allowable slope or angle of repose, and perhaps some vibration occurs, or just gravity gets it over time. The spoil pile itself can slough off and fall into the trench. So there's two ways really that spoil pile collapse can occur, either by just contributing to a collapse through surcharge loading, or the spoil pile itself falling into the trench. And that's what we're looking at here. It's a 2-foot setback that OSHA requires. Most companies will strive for a 4-foot setback. Doesn't always occur. Whoever's excavating, if they're in a hurry, if they're in a rush, it's quicker to, as soon as you pull that bucket out, drop that soil right there. it tends to slide back in. Soil tends to want to assume its angle to repose immediately, so it tends to settle in. By virtue of that, whoever's excavating may realize and begin to, okay, I got to move that spoil pile away. I'm trying to dig and it's falling back in. But there are occasions where you'll find spoil piles too close. The next is the slough-in collapse. Okay, this form of collapse can occur at any location along the trench face. It occurs by that sliding mechanism. Okay. Often ends up looking like someone took a big bite or an enormous spoon and scooped some soil out. Okay, like our ice cream. So it can occur like you see in the picture here, where it occurred up high, and you just you've lost that entire portion of the belly and the lip. A slough-in can also occur, and this is a particular note to rescuers, in a manner where the belly gives way, it sloughs into the trench, and it leaves an overhang. Usually occurs in this manner where the soil was affected by hydrostatic pressure. There's been a lot of rain. The top sides absorb the water, it's soaked down, weaken the belly. When you're approaching a trench, we'll get into it a little bit later, but this form of collapse, where it sloughs in and leaves an overhang, this is where a rescuer can, if he approaches the center of the trench, as opposed to approaching the trench from the ends, can find himself in a sticky spot. Now, the slough-in from mid-belly leaving an overhang isn't a type in and of itself. It's just it's a slough-in collapse. This just occurs in a way that it's worth mentioning. It's on its own due to the danger to rescuers. Okay, so the next actual type of collapse then is a complete shear wall collapse. Usually occurs on a vertical plane, often in areas where this excavation that has been made, well, maybe 5 years, 10 years ago, however long ago, there was a previous excavation in the area. So if you look at the picture there and you see the dotted line, perhaps that was where a trench once was. Somebody comes back later. Now we dig a trench not knowing that there used to be a trench right there. We can't tell from the top. And it creates, it's already inherently weakened cohesiveness-wise, and you get your collapse. That would occur by the toppling mechanism. Now, there's also partial shear wall collapses. This is commonly referred to as a rotational shear wall collapse. This is probably the most common form of collapse. So you still have that vertical plane effect, but at some point it held strong, like in this picture where you see the toe held strong there. Otherwise, the collapse occurs on a very vertical plane, but through that sliding mechanism. So it releases and then collapses into the trench. Another form of partial shear wall collapse would be the wedge or triangle collapse. Obviously, when we have corners in trench, whether it's T or L, those are inherently weak areas. You have open trench faces that come together and meet. They both lack support, and gravity is doing its thing. There's also lip and toe failure. Less common forms. All right, again, we have there's a slideshow on it that I made and illustrated and put just on the YouTube channel by itself. So you can watch that again if you're so inclined. Again, you can't really go out and film these types of collapses occurring, And this is just a great way to review as you're needing to do so over time, and you kind of start to forget these type of things. Good to go back and review. All right, Jason Hankins here with another trench video for you. Just informational. This is really basic kind of trench 101 type of stuff. Certainly informational. What you name the type of collapse once you've arrived on scene, doesn't really matter. But these are some of the terms you might hear if you're talking to a heavy rescue guru about trench collapse type stuff. So, one of the most basic types of collapse would be a spoil pile type collapse. Remember, OSHA requires a 4-foot offset. That doesn't always occur. Soil has a natural angle of repose, otherwise known as a maximum allowable slope. And that's that slope where gravity will naturally make that soil settle. If you pile soil at an angle steeper than that, or cut soil at an angle steeper than that, you're going to have a tendency for that soil to want to give in to gravity and fall into the trench. Just finish up this animation here. Do the animations to help make perhaps the video a little bit more entertaining than just a dry speech. You might have vibration or something in the area that helps facilitate gravity taking advantage of that spoil pile. Next form of collapse is a slough-in collapse, which is also one of the mechanisms. In a previous video we talked about the phases of collapse, which are more or less warning signs of impending collapse and the mechanism by which collapse occurs. Here you have a slough-in as a type of trench collapse. Soil breaks way low and sloughs into the trench. Possibly even trapping your worker or person. Slough-in can often be due to surcharge loading. That's heavy items in the area of the trench or very near to the trench opening. Okay, remember we park our vehicles out of the hot zone, greater than 50 feet away. Did a little graphic here of just a slough-in occurring in a mid-belly type of slough-in. It's not really a type per se on its own. It's still a slough-in collapse. However, in this warrants particular attention because it leaves an overhang, particularly dangerous for rescuers, anybody coming into the area where this has occurred. Potential to stand right at overhang. That's why when we're approaching a trench initially, we approach from the trench ends versus approaching from the side. We don't want to get caught by an overhang. Overhangs are less likely at the trench ends. So the next type of collapse that you're going to see is going to be a shear wall collapse, also known as a sidewall collapse. Very catastrophic, usually occurs fairly quickly, can occur slowly. Usually occurs on a nice vertical plane. All the shear wall collapses will occur on a very shear wall plane. A lot of times in areas where there's been previous excavation. Here you're seeing a form of partial shear wall collapse called a rotational collapse. The rotational collapse involves a kind of a slough in a very downward manner. So it gives way low, and then the gravity takes it and pushes it down and on a curve into the trench. This is where you'll often end up with a victim slammed hard against the trench wall and pinned. This is actually called a rotational failure. I didn't get that text up in this drawing. Rotational failure is a very common form of trench collapse. Here you have your wedge collapse shown. This is common to your T's, of course, and your L's. Anywhere where you have two trench walls, two trench faces meeting in an unprotected manner. So this will be a nice outside corner. Gravity's working on it. very unsupported and just gravity's doing its thing. Add in a little vibration, time, weather, drying of the soil, anything that weakens that cohesion. And this is where you'll get that wedge-type collapse. T's and L's. Very difficult to deal with, somewhat problematic for rescuers, depending on the level of the wedge. But it's a subset, more or less, of the partial shear wall collapse. Here I've shown it kind of partially up the wall. It can occur, of course, full length from the toe to the lip. The next two forms of collapse that you're going to see are a lip failure and a toe failure. Okay, a little bit less common. Lip failure usually occurs when you have a nice, very cohesive soil, nice and stable, but something in particular at the top. Here I've drawn a little guy with a jackhammer, but whatever it is, whether it's surcharge loading, vibration, maybe it's weather, something causes just a weakening in the very upper portion of the trench, and you'll have a lip failure. Not usually too problematic unless someone was down inside the trench at the time the lip failure occurred. The falling soil, falling objects from the top. If something's laying directly on that lip, you can fall down into the trench and injure someone quite severely. All right, I think you got it. All right, so the next form is toe failure. Failure just at the toe. Again, that soil, that form of collapse is going to occur in very specific conditions. The soil is very cohesive. Things are holding together well, but something in particular causes a weakening in the toe. Perhaps a high water table, large amounts of rain. Water used during a construction process, maybe combine that with a little bit of vibration, but something is weakening the soil at the very base of the trench, where normally you have some support and some strength in the trench wall. In this case, weakening it to the point that the toe fails. Of course, at that point, you have to worry about the next form of collapse that's coming. A condition that's kind of a toe failure, a subset of toe failure, that's worth mentioning is the bell-bottom pier condition. That's where the soil kind of sloughs in at the very bottom on both sides, or in the circumstance of like a pier hole being drilled into the soil. Someone's going to pour big concrete piers. They create just a circular hole in the earth. Again, add in a high water table or significant rains, and if that bottom gives way, in a circular manner, or in the case of the trench on both sides, then you have what's called a bell-bottom pier condition. Really leaves no safe place to stand or operate near the trench edge. All right, so just a little bit of review. Spoil pile collapse, slough in. Beware of that mid-belly sloughing with the overhang. shear wall collapse, okay, also known as sidewall with your complete and partials, okay, rotational failure being the most common, wedge collapse, lip failure, toe failure. Just be aware of bell-bottom pier conditions. Don't see that a lot, but very dangerous. Spoil pile. Final review here, kind of. Slough in with overhang. Complete shear wall collapse. Partial shear wall collapses. Subset rotational failure. Most common form. Subset wedge collapse. Common to T's and L's, of course. Lip failure. Toe failure. And of course, bell-bottom pier. All right. One more time just to beat this thing to death. Thank everyone for watching. Hope this is somewhat informational for you. Try to make it a little bit more entertaining than just a dry PowerPoint type presentation with the little animations. Actually, it takes quite a long time to put these things together. It's all new software to me. I'm just playing with it. I'm certainly no professional animator, but the software is kind of fun to tinker with and try to put something together that makes this material somewhat entertaining. Okay, can't really go out and film these types of collapse, so you know, the animation works for the purpose. All right. Thanks everyone for watching. All right, so exciting. Okay, so moving on to protective systems. Protective systems are something you could encounter. Of course, we're going to build our own protective system when we arrive on scene, but you'll also find them on scene when you arrive to a trench collapse. Potentially not. That might be why you're there. As you drive around and you're looking at the various construction, road construction and otherwise, you'll see the various protective systems in use. So the first protective system worth mentioning is sloping. Of course, that's cutting into the soil at a nice angle so that you don't deal with that angle of repose, and you reduce the risk of collapse sheerly by cutting the soil itself at an angle where there's somewhat of a passive energy. The angle of incline required to prevent the cave-in, that's just going to vary with the soil conditions and the environmental conditions and the level of encumbrances expected during that operation. So that's a construction industry type thing, of course. Benching also is a construction industry method. So where they're going to cut essentially what looks like steps into the side of the soil. And of course, how many steps and how tall they can be, that's all determined by the soil type. And again, the weights that they expect in the area, the encumbrances, and surcharge loading. So you're going to see benching and sloping only, for the most part, on large-scale operations. More commonly, what you're going to see and easily take note as you drive around is shielding. Shielding is exactly what it sounds like. Shielding is a method of protecting protecting employees from the dangers of excavation and soil collapse, trench collapse, by putting in this element that's going to shield them. It's rated for a certain amount of weight and a certain amount of impact. It's a static thing. It doesn't push any pressure into the soil. It's not trying to reestablish homeostasis like shoring will. It's just acting as a shield. If the soil comes in and hits this structure, the structure is going to protect the worker inside, the employees, and keep them safe. It won't collapse under the pressure that we expect to come in. So to what degree your shielding is determined by how deep your trench is or your excavation is and the soil characteristics in the area. It's a passive device. It's meant just to take the brunt of the impact. So now, shoring. Shoring means a structure such as a metal hydraulic, a mechanical structure, maybe a timber shoring system that supports the sides of an excavation and which is designed to prevent cave-ins. So it's an active system. It's pushing on the soil. It is, to some degree, trying to reestablish homeostasis. Shoring systems often are composed of a cross-brace component together with either an upright or sheeting component or both. For rescuers, of course, it's going to be both. So the elements of a shoring system, one, you're going to have your cross braces. That's going to be your horizontal members of a shoring system installed perpendicular to the sides of the excavation. Okay, in the picture there, you can look down at that bottom right corner, and you'll see that strut. That would be an example of a cross brace. The cross brace is going to be that element of the shoring system that actually applies some pressure to the upright, by which is that pressure is transferred into the soil. So the next component is the upright, and that just refers to the vertical members. They're either going to be timber, aluminum, and they're either going to be placed either in direct contact with the soil itself, as in the example of an aluminum form of an upright, is most likely where you'd see that. Or it's going to be in contact with some form of sheeting. When you talk sheeting, we're looking at, if you're looking at our picture here, so you have the cross brace there, which is in this case the Paratech strut. You have your upright. Now the upright is commonly called a strong back. That's more likely what you'll hear it called around the trench rescue environment, the strong back. Okay, but that's the upright. Then you have your sheeting. That's the big brown in the picture, 4x8 sheet. That's the fin form there. And the sheeting means the members of a shoring system that retain the earth in position and in turn are supported by other members of the shoring system. And it can be timber or aluminum. Now this would be primary sheeting here. There are subforms of sheeting like distal supplemental sheeting and proximal supplemental sheeting. We'll talk a little bit about distal supplemental sheeting later. So we do want to be on the same page as far as our terminology. Again, the industry standard terminology. We're looking at cross braces, uprights, and sheeting. Specific, a little bit more so to the trench rescue arena. We're looking at our struts, our strong backs, the popsicle stick looking piece of timber that's mounted to the sheeting. And then you have your FIM form. Together, that whole thing, those are the elements that make the shoring system. When you look at that, so look at that trench board there in the picture to the left. So minus the cross brace, what we're looking at is just a trench board, or a shoring panel, or a trench panel. All three of those names apply to that one piece of equipment. You'll hear it called all three. So trench panel, shoring panel, or trench board. That's the upright section together with the sheeting. Sometimes you'll hear a trench board or a trench panel referred to as a strong back, like they're calling that as the whole piece of equipment, but the strong back is specifically that 2x12 piece of timber there. The whole thing itself is a panel. If we want a panel in here, we're going to ask for, okay, place your panel number 1 here, panel number 2 here. Okay, it's a trench panel or shoring panel or trench board. Your department might call it something else. Just make sure everyone in the area knows what you're talking about. Additionally, when you're talking about shoring systems, there is, you'll hear in the construction industry, you'll hear spaced shoring. Spaced shoring is an option that can be done in like a type A soil. It's very stable, but they do want to provide some stability to it. What you'll see when you see spaced shoring is you'll see a cross brace with an upright, and the upright itself is placed against the soil. And the next element to the shoring system will be several feet over, leaving some exposed trench wall. This can be done in stable soils like type A soils. What we're going to be building when we're building shoring systems is closed shoring systems, where the sheeting of the system allows no gaps, no exposed soil wall. It's sheeting to sheeting to sheeting, all the way across. There also is different types of shoring. You can have your aluminum hydraulic shoring, your pneumatic shoring, and your screw jack shoring. Of course, those are all terms referring mainly to the cross bracing. With timber shoring, you're going to end up using tabulated data for from OSHA to determine exactly how big of timbers do you need, 4x4 or 6x6. What are the true expected weights of the soil at what level. So if you're going to be doing a lot of timber shoring, you need to plan on being very familiar with that document and being very, very good at performing a timber shoring operation. Just a couple examples here in the pictures. Obviously, you have your pneumatic struts here. So we have pneumatic cross braces here in the left, a timber operation in the upper right, and screw jack shoring there on the bottom right. They all offer their various advantages and disadvantages. All right, congratulations. You made it through this module. I'll let you, look on your own at the knowledge check questions. There's this slide and one more. As you read those questions, if you can't answer any of them, please just go back and review. Talk about the questions amongst your peers. Take a moment, pause the video, go out and look at the heavy rescue equipment, look at your shoring panels, and talk about the elements. You can look at your equipment and see what kind of condition it is while you're doing that. Make sure you're familiar with where your equipment's located, those kind of things. Take a break, get some coffee. We speed up a little bit from here, and we'll get back to it. A few more questions here. All right, see if you can answer those questions. Pause the video and we'll come back and we'll begin Module 3. Okay, I assume you all had a break and feeling a bit refreshed. You've got your coffee refilled. Let's get into Module 3. I'll try to talk just a little bit more openly, a little bit more casually as we go through this. This really gets into just the trench emergency response, and we'll try to go through it semi-quickly. This is the point in the slideshow where really we kind of hit the fundamentals and then get you out to the soil and start practicing these techniques and really start to teach you more and give you more information. But this module will give you a basic understanding of what you're going out to do exactly when you go out to a trench. Okay, so at the end of the module, you'll be able to state the overall phases of a trench rescue, state the primary actions that comprise each phase. You'll understand the resources required for trench rescue. You'll be able to demonstrate an understanding of the critical RO role and the questions that an RO is going to be asking. You'll be able to state and understand the zone distances required in trench rescue. Understand the division of labor of work teams required for trench rescue. You'll know how to make an edge safe. And you'll understand the basic steps that occur as you're building a trench shoring system. You'll develop an understanding of the advantages of wales. You'll be able to state the correct order for strut placement. You'll be given some options for filling void spaces. And you'll understand the panel configurations for each of the main types of trench, both straight, T, and L. So here's the basic phases of trench rescue. You have a pre-incident phase like anything, initial response, then the actual stabilization phase, followed by disentanglement, followed by physical removal of the patient from the trench environment, followed by recovering your equipment and terminating the incident. Pre-incident preparation comes first, obviously. So we need a trifecta for success here, right? We need the right people, the right mindsets. They need to come in, they need to have the right training, and they need to have the right equipment. Any element missing from that trifecta and your operation is going to suffer. You're not going to be able to perform the trench rescue effectively. If your people aren't the right type of people, if they're not self-motivated, disciplined people who maintain their skills, if they're not mentally performing well under pressure, you're going to have a weakness there. At the same time, if you take even the right individuals and don't provide them the correct training, or you don't maintain your original training, you don't build upon it, you leave your training right where it was when you received your trench class 7 to 10 years ago, you've just kind of stayed right there at that level and never advanced it, you're also probably going to suffer a bit when you go to a real trench. And then of course you have to have the right equipment. You can have the right people with the right training. If the right equipment is available to them, they're not going to succeed on trench rescue. Talking about training, you have awareness, operations, and technician level in trench rescue, just like you do in all your other heavy rescue disciplines. More recently, NFPA in 2008 went to a classification where they went away from awareness, operations, and technician just to Trench Rescuer 1 and Trench Rescuer 2. Basically, that's Trench Rescuer 1 is kind of an equivalent to operations level, where Trench Rescuer 2 is more equivalent to the technician level. An awareness trained person is someone who's informed about trenches and their dangers, kind of all the information we've more or less covered so far. And they have a knowledge base on how to perform non-entry level rescues. Your operations level technician, your person who's trained to the trench operations level is someone who's, or your Trench Rescuer 1 per NFPA 2008, is someone who's able to perform trench rescue operations in trenches up to 8 feet. Now they have to be non-intersecting trenches and require no supplemental shoring. If they do involve intersecting trenches or involve supplemental shoring, That's a technician level training skill. So your technicians then are technicians who are trained to do all the above, plus trenches deeper than 8 feet, trenches involving supplemental shoring. Okay, everything. You can go actually up to about OSHA states 20 feet. At 20 feet, you are now required to have an engineer come in and engineer you a system. In practicality, it's about 15 feet is kind of where you really, with our trench paneling, with our shoring system that we have the ability to apply, we're kind of pushing our maximum capability, honestly, at about 15 feet. Test question, OSHA says 20 feet, a engineer is required. So, of course, part of pre-incident preparation is also, just paying attention to your equipment, maintaining it, making sure you know where it is. Some of the things we do on a regular basis, as you get whales and you replace the old ones, we'll make sure we drill holes in them so we can thread the rope through easy on scene. We don't have to tie a clove hitch or a timber hitch or anything like that. We just zip the rope through and tie a nice safety knot, and it works beautifully. We have handles created in all the sheeting on our trench boards. We've got a nice rounded edge on all the timbers. Our uprights, our strongbacks are nice and smooth. They have a hole drilled in the top of them. One of the pictures earlier was a nice deep trench. You saw how the board had been lowered down into the trench hanging from the rope. Okay, so we pre-drill and look at our equipment, just try and decide, how can we make it so that this equipment's going to work the easiest and the most efficient when we're on scene. In West Jordan, we use Paratech struts, so we have got them, taped so that they're taped according to length: blue struts, white struts, red, and silver. Extensions got a double taping, so a double white or a double red. And I believe our marking system is consistent with UFAs and most of the valley departments. Through that picture there in the bottom right of the vacuum truck, because not only is pre-incident preparation, not only does that include your own training with your own department, but it should include training with other departments, including your local utilities department who may be running a vacuum truck. That's something you have to train on beforehand. You have to train on that before the incident occurs. If you wait till later or during the incident, you're going to have a hard time. Here's just another element of pre-incident preparation, trying to make anything that's done on scene of an actual collapse just that much smoother. Take out that element of having to think things through, as much as possible. It sounds kind of funny, but in the context of struts, we've made a sheet where the strut team themselves can reference this sheet. The RO can call out a measurement. Say I have a trench that measures 38 inches. RO calls out 38 to the strut team, and they can refer to this sheet and immediately, without doing any calculations, look down and see, okay, I can make 38 inches. We can hit that with a white strut with a red extension. Simplifies the thought process and makes it quicker and more efficient. You can build other worksheets for the incident. That's all part of pre-incident preparation. All right, trench response. So the initial response phase, obviously this begins when the call for help comes in. Okay, and this initial response phase then will continue from that point until the point that the RO has developed his stabilization plan and the shoring panels are beginning to enter the trench. Everything from the call to that point where you're building a system is all included in this initial response phase. So a well-conducted incident response phase is critical to the overall incident success. This is really where you're going to set yourself up for success or for failure. Now, having said that, the success of this phase really largely depends on the rescue team leader, or the RO, the rescue officer, and his ability to control the scene, establish a plan, establish adequate resources, eliminate hazards, and then take his formulated incident action plan and implement it. So the rescue team leader is defined as the person designated within the ICS system as a rescue group or division officer responsible for direct supervision of the rescue team operations. Now, in most cases, of course, that's going to fall on a captain of a heavy rescue, a captain of a ladder company, a captain of an engine company, whoever arrives first, who has this competency level to enter this role. Generally speaking, it should fall definitely on someone who is very experienced with trench rescue and has the competence to really be able to look at the plan dynamically, look at the situation, and make that plan. The reason I mention that is because you may find yourself in a leadership role. Perhaps you're the captain on a unit. You arrive to a trench rescue. If you have to be honest with yourself. If you know that you're not necessarily as up to speed on trench rescue as hey, you've got a technician here. He's recently been in trenches. He's been on the team a long time. He's very good. I know he knows his stuff. That person may be an excellent person to say, hey, I need you to RO this. It doesn't have to fall on a captain. It doesn't have to fall on a red helmet. It should fall on someone who really has trench rescue dialed in. Hopefully that's yourself, but not necessarily. Don't be afraid to rely on the expertise of team members. Of course, this phase begins with that emergency call-in. So as you're en route, you're beginning to think, you're beginning to plan. You're paying careful attention to what units were dispatched, so you can ensure adequate resources are en route. A few other just key considerations during this initial arrival is make sure you're parking your apparatus a minimum of 50 feet away from the trench. Okay, that'll be your hot zone. We'll talk about that in a minute. If you are the trench competent person arriving first on scene, maybe you're on the heavy rescue and you're getting to the trench first, make sure you specifically request all other units to hold short. This is a good step to help prevent units toppling in on each other. Similar to fires, everybody wants to get in there, everybody wants to play. One of the worst things that can happen is for a rescue officer on scene trying to make a plan is to arrive, just be stepping out of the rig when others are arriving, and everyone wants to get in there and have attention and be a part of it. And really, you need one person looking into that trench to make that actual plan. Shutting down the apparatus will minimize vibration in the area. If there's a competent person in the area, someone, an active construction industry site should have a competent person who is available, who has trench training, and can tell you, this is the work that was being done. These are the hazards in the area. This is where the worker was. These are the safety measures we had in place or didn't have in place. Of course, as you arrive, you're getting off your rig and you're observing that general area for hazards. You're approaching the trench from the end to make your assessment. Again, we're avoiding stepping onto soil where there may be a slough in. The ends are a naturally more stable area because of the walls coming together. So we approach from the ends when possible to make our first observation of the trench. There's going to be a series of questions running through your mind as RO. There's these key questions that really will help you formulate your incident action plan. Is this a rescue or is this a recovery? Is it non-entry versus entry? And how much are we willing to risk versus the likely benefit of what level of involvement? Of course, you have to consider your hazards. Potential for hazardous air. Of course, OSHA 1910.146 gives us your hazardous air parameters. Oxygen enriched at 23.5, deficient at 19.5. Your alarms for LEL set at 10%. Alarms for CO at 35 parts per million. Hydrogen sulfide at 10 parts per million. So get your hazmat people involved. Right away you have hazmat people involved. Don't be afraid. Please, hazmat 52. Please come on up and perform air monitoring. Get them involved to eliminate and assess for that hazard. Water is a natural hazard that's often present in the bottom of trenches, either due to a high water table, or utilities in the area, or environmental impact. It's been raining for days, which seems to happen miraculously as soon as we cut open a trench for training. Of course, there may be actual utilities in the trench. That 811 number should get you some information on utilities if there's no competent person in the area. However, hopefully you have a competent person and they can readily identify those things. There may be utilities in the soil that you can't see, those subsurface encumbrances. So you need to get a good assessment of the entire area, including things you can't see, and that's where that 811 number comes in, or a competent person from the area. Of course, there's always personal injury hazards, whether that be trip and fall, cut hazards, those things. So look out for those things also, common to construction industry areas. You may need to support utilities. That may be a very early consideration. Definitely will impact your action plan. That slide may be getting a little bit ahead of myself, but of course, anytime you support a utility, you need to consider if what you're doing truly will support the utility. If you're supporting a pipe, how heavy is it? What's involved? What do we have that'll support that amount of weight? Okay, when you're talking hazards in trench, well, trenches are confined spaces. All trenches are considered by OSHA to be confined spaces. However, a trench is an excavation and therefore is exempt from OSHA 1910.146 in most instances. I say most. There are instances where compliance to the confined space standard will be required. Of course, constant compliance to the standard offers the best safety and liability protection. However, of course, that's highly impractical in most heavy rescue situations. 29 CFR subpart P is a construction industry standard, and its application to rescue personnel is at the discretion of your local OSHA officials. At most times, it's perfectly acceptable to perform a trench rescue without confined space equipment on. We don't need our SCBA on. We don't need supplied air, so long as there's no hazardous air condition present. If there is, then obviously that changes the game and we need to comply with the confined space standard. But trenches are confined spaces. Okay, back to those primary questions that if you've arrived on scene and you are RO, the success or failure of the situation, very heavily can be determined by yourself. So one of those first early questions is you're assessing that trench for, is this a rescue or is it a recovery? Are we going in to save someone who's viable, or as I peer into the trench, is this person non-viable? Are there injuries inconsistent with life? So as you peer into the trench, observe obviously for the victim location and condition. If you can't see him, obviously you're looking for clues. Are there helmets? Are there tools in the area? Where is this person? Are they alive or are they dead? In the picture here to the right, this was a trench collapse that occurred in West Jordan. And you can see the tools laying on the pipe. You can actually even see, it doesn't show it in the picture, but you can see the hand marks where, upon being pinned, the gentleman struggled to get himself free from being pinned, and it was able to do so before rescuers got there. But you're able to see those signs that had he not been visible and still down under the soil, you would have been able to tell where this person was likely located. And remember, even if they are not visible, it's not impossible that they will survive the trench collapse if there's been some lucky factors involved. Was there something that shielded him from the collapse directly, but he's possibly still pinned under soil? Did he make it into a pipe? Sounds like a weird situation, but there is a story of a trench collapse where an individual made it inside of a pipe and survived the incident. Most complete burials are fatality incidents. So obviously this is a key question because it really is going to determine the rest of the operation. If this is a recovery, then we're going to go slow. We're going to go by the book. When it's a recovery, that risk versus benefit analysis comes into play, and there's not a lot to gain by risking a lot. So we're going to risk very little to benefit a little bit. Whereas if it's a rescue, of course, we're going to move completely different with a completely different mindset than that of a recovery. So upon the point where you determine that you need a rescue, then it's a matter of, okay, is it a non-entry rescue or is it an entry-level rescue? Is this someone who is down in the trench and is down there because the soil collapsed, destroyed the ladder, and he's just stuck down there? Good example of a non-entry rescue. Throw that guy a ladder and let him rescue himself out. Maybe it's someone who's had a heart attack and there's no collapse at all and they're just down at the bottom of the trench. Are they conscious enough to be able to help themselves out if supplied a ladder? Is it somebody who's injured but minimally injured? So anybody who can help themselves out to slight various degrees, we can provide them a ladder. Maybe they're minimally entrapped and need a shovel. We can provide them a shovel, provide them a ladder. As we begin to make maybe a plan for additional things, maybe you throw him a shovel, give him some instructions, reassure him, and then you start to make your edge safe and do these other things to kind of move the operation forward. But in the meantime, he's digging himself free. So there's a good handful of scenarios and options that could lead you to performing a non-entry rescue. Now it may be that it's a entry-level rescue. An entry has to be done. The person is trapped to a point where they couldn't possibly dig themselves out, which pretty much will be anything above, anything above the knees. Soil is incredibly heavy. It takes a lot of effort to move. So when people are trapped, once you have soil levels above the thigh level, you're really you're talking a lot of soil and a lot of time also to get that person out. So those can be entry level rescues. They may be perfectly conscious and able to talk to you, but you may have to send people in there to facilitate getting them out. Of course, there's going to be those conditions where they're heavily buried but still viable and need immediate help. This is a level of rescue that demands extreme urgency. You may find when you arrive on scene to look down into the trench that there are family members and friends down in there that are not injured and not trapped. They're trying to dig out a loved one, trying to dig out a friend. And of course, those really have to be addressed on a case-by-case basis. As an RO, you may have PD on scene and explain to PD to see if they can do anything to coax them out of there. Otherwise, you might just note that they're down there and proceed with an entry-level rescue operation. Very likely, those folks are highly emotional. They're highly motivated, and they're highly they're not going to stop and listen to you just because you say, "Hey, that's dangerous. Please get out." Maybe they will, but okay, you may have to just kind of note their presence and continue your rescue operation. If you can get them out, great. So I mentioned it a little bit already, but that risk versus benefit analysis. This really determines so much in how you're going to operate. Are we willing to risk a lot to gain a lot? Just to expound on it a little bit, I peer down in there as an RO, and I see that there's someone who's pinned just above chest level, just below the neck. They're beginning to get cyanotic, but he's moving his head a bit. I can see some, there's definite signs of life. This is one of those incidents where the risk versus the benefit tells you, okay, yeah, we can risk a lot here to save a lot, and we'll move differently. I'm not going to move necessarily step by step by step. I'm going to be trying to accomplish as many tasks at one time as possible and as quickly as possible. We might throw one set of panels in right at the patient's location, get a middle strut shot as quickly as possible, and be lowering a person down into that trench box to begin digging, while the rest of the rescue operation proceeds behind that, continuing to build shoring boxes, continuing to progress things forward, but with that adjustment of moving quicker, getting directly into that patient in a quicker manner. Whereas when it's a recovery, of course, you're moving step by step, doing things as safely as possible and by the book, so that you're risking very little. Of course, the risk versus benefit analysis is always ongoing. At all times, each step of the way, anytime any major benchmarks, any major developments, always conducting this risk versus benefit analysis. Maybe you're in rescue mode very early, and then it becomes recovery mode. Maybe you're doing one thing and additional sections of the trench begin to collapse. It very much changes the game. So we talk zones in heavy rescue. 50 feet in all directions from the edge of the trench, that represents your hot zone. It doesn't have to be a perfect circle. That general area, 50 feet from trench edge, is that area where you really want to have an equipment cache of your immediate needed equipment. Otherwise, the heavy rescue is parked just outside of that area. A cut station is outside of that area. Keep your hot zone for your technician level personnel or your manpower personnel. It may be, depending on availability of your manpower, or availability of your resources, that you only have 5 technicians on scene for a moment, and your hot zone needs to be filled with anybody and everybody who can get hands on. But ideally, big, large-scale incident, we'll try to fill our hot zone with technician level heavy rescue technicians, maybe a technician level hazmat person for air monitoring, those kind of things. The hot zone is reserved for people intimately involved with the rescue operation. Your warm zone extends from that 50-foot marker out to your cold zone, and that's where you put some of your semi-essential personnel, your cut station, your rehab area, those kind of things. Incident command. And then, of course, beyond 150 feet, your cold zone. Now, don't honestly see a whole lot of building of zones. You're not necessarily getting out your fire line tape and making perfect circle zones as we do most trench collapses. However, if it's available, one nice way to make a hot zone is to, if you're passing through a construction area, if you're going into that type of an arena, then look for gates that could be closed behind you and used as a singular point of access. All right, so work teams. Trench rescue is extremely manpower intensive. There's a whole lot to be done, and in the situation of a rescue, it needs to be done all very, very fast. When we talk about recovery, we'll move through those slower, but still the same amount of work is going to be done. When you talk work teams and the division of labor, you're going to need an entry team, at least one, if not two people or more, depending on the trench. There's a panel team, sometimes called an edge team or a lip team. So your panel team is really is responsible for facilitating all those operations that need to be done, all those skills that need to be done topside. On the surface of the soil, they're moving the, of course, ground pads that we'll talk about here in a little bit. They're getting out the ground pads. They're clearing away spoil pile that might be in the way. They're getting those laid down. They're pulling out trench boards from the rig, walking those over, getting those set in place, prepping them for lowering. And once trench panels are in place, the panel team then typically is the guys who are standing topside near the panels, lowering down struts, lowering down various equipment that's needed. You're going to need a strut team, at least one, if not two or more guys, putting together struts as the measurements are called out. These guys should be sharp and on the ball and anticipating the needs of the trench. So as soon as they have a general measurement, they can start building struts one size as the size that's been determined or called out, and perhaps building one size a strut above and below, having those options available. If you have a predetermined strut build sheet, that helps the strut team a ton. You'll have an air team. On many trench collapses, you'll have a singular air team, one guy or two guys running the air for the struts, but you'll likely also need a guy on the air team who's running the air for airbags, high pressure or low. So you can use several people there. A RIT team is a good idea. That team can also be the team that if your entry team becomes exhausted or needs rehab, then that RIT team can take the place of the entry team. The entry team, if I didn't mention, is the guys that are actually going into the trench. So they're getting into their gear, they're getting harnessed up. And of course, consider hazmat. You may want an entire hazmat team just at the ready Maybe you have utilities in the area, gas that needs to be shut off, water that needs to be shut off, sewage. So as the RO, you're always looking out for that rate limiting step. It's worth mentioning here when we talk about teams, just because um, you know, as you're assembling things, as you've made your action plan, you've determined how fast or slowly you're going to move. Um, you can determine to move fast, that this is a rescue, we're going to move fast, and depending on the order that things are getting performed in, suddenly you can be dealing with this factor of this rate limiting step. So, for example, we arrive on scene and we determine we want to move quickly. We've got somebody who needs immediate rescue. I assign 2 guys to get into their gear for being an entry team. Their protective equipment, their harness, their tagline. Well, those guys begin to get ready, and you suddenly find yourself with 4 guys for a panel team. It's going slow. They're struggling to get that done. The entry team comes up. They're ready to enter the trench, and yet we don't have our first or second set of panels in. Suddenly now the panels is the rate limiting step, and you need to make sure that those entry team members aren't kind of standing there idly by to do their task. If they've put themselves on a tagline already, you take them off the tagline and say, hey, we need you over here doing this. So you try to. That's one small example of a rate limiting step. There's many different examples. It's that thing where you meet that time where okay, now we can't move any further forward until this thing happens, and until that happens, everything else is held up. Everything else might be ready to go, but we can't advance on it until this piece happens. And that's one of those things as an RO you have to be watching for, trying to think ahead, trying to anticipate, watching the guys who are on your various teams, and making sure they're all in step with what the next immediate goal is in your plan. It's no small order, no small task. One of the things we're going to do very early on in the incident, in this initial arrival phase, is we're going to make the edge safe. We're going to do that by placing ground pads around the trench anywhere where we anticipate rescuers are going to be working. You may need to level the soil around the trench, move spoil pile. So we're going to take out these ground pads, and those ground pads are just going to be these 4x8 sheets of plywood. Hopefully good thick stuff. And it's going to go around the trench area. You're going to overlap those boards by 6 inches. And here you can see in the picture that the RO determined it was feasible and important to spray the areas where there's undercutting or soil missing from underneath the ground pads to alert rescuers to the presence of a weak area. These ground pads are going down for the purpose of distributing weight throughout the soil, so we're not putting a ton of weight, or we're reducing the pinpoint area where we're applying weight to the soil surface. So we can overcome that by piling tons of rescuers onto single ground pads. So we strive to maintain a rule of 2 rescuers per ground pad during the operation. A lot of times during training, of course, we kind of forget, and we all want to see down into the trench. But at all times, we should strive for no more than 2 rescuers per ground pad. Now, throwing down ground pads usually occurs simultaneously with placement of ladders. We want to get a ladder down there into the trench as quickly as possible so that we are offering our own rescuers an escape route. Should a rescuer by chance slip and fall into the trench, lovely.
Call from one.
Okay, sorry. So we want to get ladders down there into the trench as quickly as possible, just to offer our rescuers a route of escape in case, by chance, somebody takes a tumble and ends up down there. You can hopefully pick themselves up and scurry up the ladder. According to OSHA, we want no more lateral travel required than 25 feet. Of course, you're going to look at the anticipated work area. The RO is going to know where he wants his trench panels going, and you'll be able to look at that and go, okay, this is where our panels are likely going. This is a straight trench. Okay, ladders here. It's not very likely you're going to actually have any incident where you'll require more than 25 feet of lateral travel for your ladder placement. Ladders extend at least 36 inches above the landing anytime possible. When you place ladders into a trench, you can do so placing them kind of along the trench wall, as you're looking at this picture here on the left. You can see they've just slid the ladder down and it's resting against the trench wall. Or as just like in the top picture there at the top right, you can see they're at the trench end, a beautiful place for ladder placement. This is good early on ladder placement. At bottom right, you see they've built a bridge. Go back to this other picture here. That's a beautiful bridge right there. Okay, but building these bridges, not very feasible early on in the incident unless if you're doing a recovery, if you're moving slow, if you have a large amount of manpower, then sure, build these bridges right out of the chute. It makes it so that the rescuers operating down in the trench can easily turn and scale the ladder if they need to. The other form of placement, where it's resting against the trench wall itself, is a little bit more difficult when the rescuers are down there, and if they need to make a quick escape, you have to kind of get to the ladder, turn, and then try to get up and make sure that you didn't scurry and hit that ladder with enough momentum that it begins to fall into the trench. So those bridges there, built in this case is built with 2x12 lumber, are very nice. But depending on your rescue mode, if this is a recovery and this is early in the incident and manpower is limited, don't let there become a rate limiting step develop by allowing somebody to sit there and hammer in these boards to make a bridge. It is not that essential. Get those ladders placed early on, make the trench safe, and proceed with the rescue. As you get more manpower available and things develop, yeah, sure, build the bridges. Or don't. Okay, so you're going to build a tool cache. Again, very much depending on the rescue mode. If this is a recovery and we're moving fast and this guy is in immediate danger down there, if resources are limited at all, if manpower is limited at all, don't spend a lot of time building a single, throw out a tarp and throw out all our equipment first and lay it out. Your equipment's going to be coming off and as quickly as possible going to be entering that trench. You will have a small cache, built with struts very early on. If this is a recovery mode, sure, throw that tarp down and build a nice cache as you make it a very nice plan. A nice way to build a quick cache, or to get yourself set up real fast, if you are a strut team or an air team, something you can do that really adds some speed, different from throwing down a tarp, is to throw down a ground pad for yourself just off of the trench and use that as your placement spot. That way the ground pad protects your tools as you have them there, and it doesn't take long at all. Okay, so if you need a break, now's a great time to do it. Pause the presentation, go out, talk more about trench rescue, ask questions of your trench rescue competent peers, throw things back and forth, talk about any differences in terminology, talk about those early initial arrival phase, those things there. Discuss what you would do if you were the RO, or if you were on an engine crew, not necessarily trained up or spun up on your trench, and you arrived first. Talk it over, take a break, refill your coffee. All right, moving forward. You've got your coffee, you got your Monster. Here we go. So the stabilization plan. So we've considered our rescue versus recovery. We've considered our non-entry versus entry. In this case, decided we need to do an entry, and we know our risk versus benefit analysis. So next thing on my mind as RO is as I'm gazing into the trench, gazing as if I'm just loftily staring down there. As I'm looking into the trench, very early on in my mind is, how am I going to stabilize this? I know I've got to get down there and rescue a guy. What's going to be the first step to get this situation moving towards stability? So your stabilization plan specific to trench rescue, looking down, one of the first questions is whales. Am I going to use whales or am I not using whales? You want to ask this question to yourself early, because if you are using whales, as soon as ground pads are down, the placement of a whale into the bottom of the trench, or 2 whales into the bottom of the trench or more, is something that needs to happen now. As the plan develops, maybe you're stabilizing, you're planning on using whales, but now you have a strut in place, your panels are in place, you shoot a middle strut, and then you decide, oh, shoot, I had wanted to use whales. Suddenly, you can still do it, but it's very problematic. And I've seen this happen before, where very early on, the RO gave an order to an individual to begin to prep whales. He was anticipating the use of whales. That was part of his action plan. And then right alongside it came panels, came the first strut, got shot, and then it kind of you see that light bulb click of, oh, we need that whale in there. And yeah, it can be done, and I've seen it worked, but it's very difficult. So look down into the trench and decide, am I using whales or am I not using whales? We'll talk about inside whales and outside whales here in just a little bit. But that'll be one of your early questions. And then, of course, you're looking for where you want your first panel. So hopefully those panels are coming very fast if this is a rescue. And you'll be ready to guide them right where you want that first panel to go. Second panel, third panel, fourth panel. Some ROs will spray on the ground pads, numbers where they want, number 1, number 2, number 3. You may or may not do that, as long as an RO you are on the ball and watching everything come together and catching it all as it's happening. So proceeding now, assuming we're going to set panels. So if we had wanted whales in there, we would have put some in there already, depending on what type of trench it is and what we're going to be doing, outside whales or inside whales. But I'm going to proceed. Can't talk about everything and show you everything at the same time. So going to proceed now with some steps of setting panels. So the first step in setting some panels is pulling the panels out and preparing them properly with the ropes in the right way. Know how to prep your panels. There's a video on that on the YouTube channel. And that's another thing you can be doing as you pause and take breaks. You can view other videos, skill related videos for the slideshow. So depending on what form of lowering you're going to do, you're going to prepare your panel. It'll be pretty much the same for both, just a little bit of difference for an opposite side panel set. So at least 2 people per panel during their placement. They are heavy. 3 is good. And you're going to use the same side panel set where you slide that panel along the trench wall on the side you're working on, or you're going to use an opposite side panel set. Generally, you're going to place your panels to set and achieve a protection area measuring 12 feet in length. And that first set of panels is normally going to go right as close and offer as much protection as we can offer to the victim, or patient, I should say. So here in the picture on the left, you see they've prepared for a opposite side panel set. They're actually going to lower that trench board along those 4x4 posts, and then that rope will be wrapped around the top of the upright or strong back and thrown across to somebody on the other side, who will grab it and then pull it across. Or alternatively, if they're not able to get somebody onto the other side due to the presence of a structure or piece of equipment, then they can use pike poles or various tools. Rubbish hook works better to push that board up along that side of the trench wall. Pardon. Top right, you see them using a same side panel set. They're going to lower that board down along the trench wall right where they're working. You can see they're actually using 3 rescuers to do that. Gentleman to the upper right corner of the picture is holding some pressure with the rope, supporting the weight. One of those key things to do when you're lowering these panels is to keep the top of the board pushed out so that the bottom of the board pulls snug to the trench floor toe junction area right there. Bottom right corner, you see a picture of the panels are in place. Now with tying back panels versus not tying back panels, it's something to be discussed, something to be just mindful of. I've seen it done in limited manpower situations. I've seen it work where it was very nice for rescuers to drop the panels and then tie them back and get their hands free to go do other things. I've also seen it in limited manpower situations become a complete cluster that would have been very much faster, better to just drop a panel and hold it and leave one person on a panel. Normally one person can actually stand between 2 panels holding them up once they're resting on the bottom of the trench floor, and he can hold 2. And then he's dedicated to that task until a strut is shot, at which point then he can pull himself free. But a lot of times that'll be quicker than trying to tie things back. You're tying things back, you're hammering in pickets, you're creating that vibration. Just depends on the situation and the rescuer's proficiency at performing the rescue. Practice both and see how it works for you. Practice, give yourself a very limited number of guys and see how it goes. Do a trench where you tie the panels back after lowering them initially and see how long it takes you, versus lowering panels in and having one person hold 2 panels when possible, and just putting people on panels until you get struts shot. You'll see quite a difference. Okay, the pre-entry briefing. So this is one of those things, again, the manner in which this briefing is conducted really is going to be determined by the mode of rescue, rescue versus recovery, right? Are we doing a recovery? Sure, let's get our equipment down nice and slow, ground pads, ladders. Let's pull back. Let's get everybody on their various teams assigned very nicely. Firefighter A, first initial, last name. Firefighter B, first initial, last name, assigned to the strut team. okay, firefighters this and this, assigned to this team. And you write it all out and you be very specific. And you huddle everybody up and you have a little bit of a briefing. Hey, this is what we've got. This is what I see. This is what we're going to do. This is my plan. And these are the hazards you need to be aware of. Alternatively, rescue mode. Someone's in immediate need of rescue. I would submit to you that the pre-entry briefing needs to be microscopic. The pre-entry briefing at that point might be the RO just yelling audibly to people as they perform things. Hey, he's right here. This is where I want the first panel. Watch out for that tripping hazard right there. Everybody see it. Okay, you and you. Engine 52, you've got panels. Engine 55, you've got this. Or it may be you and you grab this, or it may be, hey, everyone right now, this is a rescue. He's buried up to his chest. Everybody on panels now. Everybody do this. So, don't get caught up with thinking you need to conduct a very organized, systematic pre-entry briefing. It's going to be very situation dependent, and you need to be adaptable to that. It's I have seen it where we gave everybody a situation of this is absolutely an impending rescue needed, and then you watch everybody stand back and have a powwow pre-entry briefing. Then it's great, very nice, except your patient's suffocating very quickly to death while you talk about your operation. So. Now, recovery mode, sure, I'm all for the very textbook pre-entry briefing. Okay, so strut placement. With pneumatic struts, Paratech or Airshore, whatever you're using, you're going to place your struts in a middle, bottom, top order. If you're using lumber, if you're going to go lumber, we're going to go from the top down. It's just safer to do that. The middle, bottom, top order for pneumatic struts offers early stability to the belly of the trench. Remember, the belly is the most likely area of the trench to collapse. And it keeps our panels nice and upright, nice and vertical when possible. Whereas if I were to very early make the bottom strut my first strut, if I lowered a pneumatic strut to the very bottom and we had that strut shot, what you'll see is the tops of the panels begin to tip in away from the trench wall, and you have a very narrow measurement at the top, or vice versa for the top. If you apply a top strut first, you're going to kick out the bottoms of your panels at the floor of the trench. When placing that first middle strut, a rescuer can assist with that. Rule of thumb is to not descend any deeper than your waist into the trench at that point. As soon as it's shot, you can enter a little bit further, spin the collar, lock it, and get out of there. Or enter the trench, as the case may be. So you put that middle strut to the middle of the trench. Now, you have to be mindful as an RO and as entry team members down in there that the middle of the trench board is not always the middle of the trench. So you have to pay attention to that. When placing a bottom strut, that strut should ideally be 2 feet from the trench floor. Trench floors are not always uneven, so you have to be a little bit adaptable. And the top strut 2 feet from the trench edge. Good habit for the RO to do is to put himself at one of the trench ends or at an area where he can kind of see the overall operation, see what's going on down there inside the trench, and he can be a lot of times the best judge for strut heights. When a strut is in place and ready to be shot, of course, entry team members, you make sure your hands are clear of the bases. That's one of those safety things that can really give somebody a bad day in a trench collapse, training or otherwise. A lot of times I like to have the entry team members be the ones that are calling the commands and no one else, because it is the entry team members that have their hands on the strut and they know best when their hands are clear. Sometimes the air team can't hear the entry team very well, so at some points it may be more prudent to have the RO call for the pressures. Once there is pressure on a strut, spin that collar down and get it nailed in there as quickly as possible. The nails are just to support the strut if by chance we lose pressure and they don't fall just loosely down into the trench. I don't remember if there's a slide coming up on it or not, but when you're shooting Paratech struts, 250 psi is the end goal in an ideal trench scenario. Whereas I believe, and you can certainly you can correct me if I'm wrong, but the Airshore system, if you're using Airshore brand, that's those red pneumatic struts, the maximum pressure should be 200. Very same principles whether you're using Airshore or Paratech. The Airshore has a means by which to spin the collar and and lock it down into place. And of course, Paratech uses those Acme threads. So when we're replacing struts, this is where we get that rule of fours. Okay, when you're thinking that rule of fours, you think back to the early slideshows and you think of that arcing soil principle. We achieve within the soil these overlapping cones of pressure when we obey this rule of fours. Beyond that, you weaken that arcing soil principle and you leave some potential for collapse. There's always some potential for collapse, I suppose, but you leave more potential for collapse. You leave a weak area in the concept of your stabilization. The rule of fours applies horizontally and vertically. So between any two struts, there should be no more room than 4 feet. So if you look at that picture there, from the bottom to the top strut, and that first set of struts that's very near the ladder, you see there's no more than 4 feet between each strut. In fact, in this situation, you have probably no more than 4 feet between the bottom and the top strut, which creates that situation where you could, if needed be to create space, you could remove that middle strut. Now when you're using whales, the rule of fours on a horizontal axis, in reference to struts, there's an exception made there. When we're using whales, we can go a distance horizontally. Horizontally, we can go greater than 4 feet because it's the whale itself that is acting as a strut to apply pressure to the upright and the sheeting. So we're really still obeying the rule of fours. It just happens to be that horizontally, our struts are further than 4 feet across. Again, everything's about communication. If you're on the entry team, I prefer to have you calling out the commands, but there are times when it's more prudent for the RO to do so. Whoever's making the commands, it has to be clear, it has to be audible, and it has to be very specific. So when we talk about lowering struts and the communications that are going on, it's really communication between the air team and the strut team. I'm sorry, not the strut team. It's communication between the entry team and the air team. The air team is the one on the other end who's going to apply pressure into those struts. You likely have your own format within your department by which you communicate for this purpose. With West Jordan, I think most of our Valley departments, the communication will go something like, okay, all right, if you look at our picture there, our rescuer, he's the entry team member there. He's on a strut. It's got a red hose line on it, and it looks like he's ready. His hands are clear. He may communicate out to the air team something like, up on red 150. And that communication should go nice and clear out of the trench. The air team hears that, and they should repeat back. Up on red 150. And at that point, the air team will shoot the strut or pressurize the strut. Okay, and as an air team, you can say something like shooting, or call out an additional command to let them know you're actually pushing the button. But the entire time, the entry team, as soon as he calls out that command, and especially when he hears the air team repeat, up on red 150, he should know that that pressure then is coming, and his hands should be clear. As soon as the pressure is actually achieved, the air team will call it out again, up to 150. Okay, at that point, the entry team members, securing the collar, taking those steps, securing the base plates with nails into the lumber. He's assessed the situation, and then he can call for his next pressure if so desired. So if you wanted to go up in this instance of Paratech, ideal situation, soil staying stable, we choose 250, up on red 250, and the communications repeat. All communications are tried to, we try to limit those to essential communications only, and again, just nice and crisp and clear. So let's actually take a look at some of the methodology behind the trenches, both straights, T's, and L's. With a straight trench, you're going to stabilize that typically with 6 trench panels. That gives you your 12-foot long, nice stabilized area. You've got the arcing principle in place in several, throughout that 12-foot area. So you're going to lower a total of 6 panels. Each panel is paired with another. And you pressurize struts from one upright to the upright across from it. You can see that you have middle, bottom, and top struts in place. Generally, you'll have, in a straight trench, you'll have one rescuer working from one end and a second rescuer working from the other. If feasible, you could, in theory, have 2 rescuers working from each end. Depending on the situation, you may also choose to have rescuers enter a single end and work toward the patient. If it's an immediate rescue, you may drop a rescuer down into, you may get your center panels in place, drop a middle strut, and lower a rescuer right in there, in which case, as the system comes in to be built behind him, he'll work outwards. Most likely, if you've done that, your rescuer there is paying just attention to getting soil off of the patient, and you have other rescuers then building from the outside in. Here's just your example. Nice remedial drawing. Okay, this represents your straight trench, victim in the middle. First trench boards go in to protect him, and then additional boards get built on the outside. With your sheeting 4 feet across, you end up with a total of 12 feet protected area. Now, so far, I think we've had pictures all involving the use of whales. You can do that straight trench without the use of whales. If you are going to use whales, there's times when you do that. Whales are utilized primarily to create a greater amount of workable area for the entry team and to facilitate patient removal. So what it allows you to do is it allows you to remove the middle set of struts. Here in the drawing, as remedial as it is, it demonstrates for you how you do not have a set of blue struts in the very middle of that, and that becomes a nice open work area. So 6 trench boards in total, pressurized with 4 wales and 4 cross braces is what we've got here. You can see it here in the picture. You can see how those in the left hand side of the slide, we have the workers working with a Stokes basket, I believe that's down there, and they've got, you know, they'd like to have more room if possible, but they've got a good amount of room. You can imagine with a middle set of struts in place, how much more difficult. You would not really feasibly be able to lower in that Stokes basket the way they've done. And again, on the right side, you see it again, just how much space and availability of area that using the wales can give you. One technique is using outside wales. Typically, this is done when you have a large section of the trench wall that is given away and collapsed, and you're looking at such a missing portion of the wall, you're not quite sure what you're going to do to fill that void space or create a system where you can apply pressure into the wall. You can use these outside wales to kind of span that gap. Apply trench boards to the opposite side of the wales, and that's what your sheeting will push against, is the wales that span a distance and hopefully capture some of a stable wall. You can fill the area behind the outside wales with high pressure airbags, low pressure airbags, and various things to try and get some pressure going from the strut to the upright, to the sheeting, to the wale, and through your, say, low pressure air cushion and into some soil. Those wales being 6x6 beams do take a lot of weight, do take a lot of pressure. Here you can see some examples. So the gap in the wall was noted very early, and the RO chose to use outside wales. So that was done right off the bat, and then panels came in behind it. Or panels came in after those wales were in and over the top. Here's an example of outside wales being used in conjunction with an inside set of wales. This is a looks like it's a T trench, so he needs the inside wale there, and he's spanning that large gap where soil was missing using the outside wale technique. You are going to have void spaces in trench. They don't all need to be filled, but any significant void space that threatens the integrity of the system does need to be filled. Anywhere where you have a large gap that's going to cause your boards to move and lose contact with the soil, as pressure is placed on them, can be filled with airbags of various natures. High pressure airbags work sometimes. You need to support those. Connect all your airbags, everything you're using, to webbing, to rope, utility rope, so that you can control it and retrieve it if needed. Here on the left you see the example of a low pressure air cushion. You can use sandbags. They're a little bit difficult to control. They don't offer you any active pressure. You can adjust them once they fall into place. Depending on your system and what's going on, they may go where you don't want them to go. Not my preferred thing to use. However, they may be readily available. They may be right there on site, and it might be one of the only things you have. All right, onto the T-trench. So it actually begins to get really wordy and really difficult to try and talk you through all these phases of T trenches and L trenches. There's just a lot to be said. There's a lot to be pointed out, and it really goes so much better when you're on site. So I'm going to keep the T trench and the L trench fairly simple in their explanation. And as soon as you can get out to a T trench and an L trench, fantastic. Get with your people who know trench rescue and let them show you and familiarize you with how to stabilize these. For a T-trench, generally speaking, you're going to use 7 trench boards and 2 wales. You need the 2 wales on the top of the T. The primary area where collapse is likely to have occurred is at the corners. The corners are, again, unsupported and weak, weaker than the rest. With a T-trench, if possible, pressurizing all your struts simultaneously, 3 struts at a time, middle, bottom, top. All your middles first, all your bottoms second, and all your tops third. That's the best way to go about things. You can't always pressurize all 3 at the same time, depending on what equipment's available to you. If you're not proficient at that or don't have the equipment available for that, I recommend that you look into seeing what it would take to get that. It takes a little bit of practice to get everybody on the same page and able to lower all 3 middle struts in place, have them all ready right at the same time, so you're not waiting one on the other. But it can be done, and when it is done efficiently, it's a beautiful thing, and it really speeds the operation dramatically. And it creates the safest pressurization scenario, so that we're not applying pressure into one portion of a trench wall while we have an open area on another that's not receiving any pressure. You need to avoid that. Some pictures of a T-trench in progress. Again, please feel free to pause the video. Those of you who are familiar with trench rescue, you can look at it and help create some discussion as you look at these pictures. You can see various things going on. So to give a really simplistic overview of a T-trench, worst place for your victim or patient to be is right there in that middle top of the T unprotected area. We can lower trench boards in a manner that captures the corners. If you're looking at that upper right picture, you can see how that leaves one section of the trench wall with no trench board there. There's no way you can partner a trench board with another trench board across from it there at that location. So you need a way to be able to put a trench board there and apply pressure. And that's where that set of wales at the top of the T comes into place. You can see it. You can see it there. If you look there on the left, you see your trench board on the right and the left are pressurized with the air shores. The middle trench board on the top of the T is not pressurized with any strut, but will be pressurized with those wales. In that picture, you actually have some gap there between the wale and that middle trench board, and that will be taken care of with some wedges. Then you have your L trench. That's the most involved trench of the trenches to stabilize out of your basic 3, straight T&L. To be done the most correct really requires 10 trench boards. Of primary concern is that inside corner. It's unsupported and likely the area where the trench has collapsed. And because it's a corner, yep, it creates that stabilization challenge. Here you can see how they've used various methods that we'll talk about in a more advanced class to stabilize this L trench and to put pressure into that corner. There's a lot of angles involved in the L trench, and if you're not paying attention to angles, as you can see in that bottom right corner there, if you're not paying attention to the angles, then you can destabilize the entire system. Those angled struts are only shot at a half pressure to whatever the other ones are, just for that reason. But again, that's really kind of beyond the scope of this slideshow. Here's a simplistic view. Very briefly, we'll talk about supplemental sheeting. Distal supplemental sheeting is required once you've been doing a rescue process that's required you to continue to dig down below the area of your sheeting. The trench was, you had a significant collapse. The soil material that came in filled your trench up to a certain degree. Your patient's buried, and you're really having to dig down to get to him. And you discover that you've actually had to dig down quite far. According to OSHA, below your sheeting, you can have no more than 4 feet of exposed soil. So once you're 2 feet past the bottom of your strong back, okay, that puts you at that marker where you're actually 4 feet below your sheeting. At that point, some supplemental sheeting does need to be applied. Here you can see an example of rescuers attempting to place supplemental sheeting. This is distal supplemental sheeting. It's actually very difficult. These guys were ready to wring my neck. Had to actually had them dig down quite a bit until they had accomplished this. And because beyond this point the trench wall is of course is going to be uneven, it's very difficult to apply sheeting, even when you're just trying to slide it in behind the strong backs. They didn't make them go a full 4 feet down, but you can see the principle. If needed to, they could cut another section of 2 by 12, place that in the middle of those two, and apply a strut to it. So anytime you're building a shoring system, if you're questioning your system, if you're questioning the stability, then you can always add additional uprights to each panel, additional 2 by 12s, add additional wales. You can continue to build your system up. If you're ever truly concerned about your shoring system, you can have it engineered. Pull it out. Even if you're not 20 feet deep, you can consult an engineer and have them assist you in the construction of your shoring system. The construction of your shoring system really is the part of trench rescue that I enjoy. As we've practiced over the years, we've always tried to change up the trenches. Deeper trenches, wider trenches, narrow trenches, cutting out deeper gouges from the trench, working to actually cause collapses to occur, various natures, watching them occur. Dealing with those, purposely cutting uneven trench floors, putting variations in the trench walls. Whatever the situation is, it's very the fundamentals stay the same. You still need that fundamental pressure to restore homeostasis to the soil, and it just becomes, depending on the situation, an interesting challenge on how to achieve it. And as you watch rescue teams work through the different challenges, it's very neat to see the different thought processes and the different things that get done to accomplish it. Okay, so at that point that the trench is stabilized, things are stable, you have pressure in there, it's very safe for your rescuers. Now it's time to begin the disentanglement. Now, again, most of these phases, especially in a rescue mode, occur simultaneously. If you have somebody half buried and struggling to breathe, you're going to get somebody in there performing disentanglement while the stabilization phase is still in progress. In the recovery type scenario, you're going to accomplish each step by step, one at a time. So the disentanglement phase begins when we really start trying to get the patient free of whatever it is that's keeping them inside the trench. Now that could include concrete piping. That's it might not be soil. It might not have been a collapse. Maybe the worker was down there and he was doing some work, and the pipe broke free of a chain support or whatever it was that was holding it in place, and now it's the pipe that's on top of the person, but a collapse has not occurred. Or it can be a combination of things. But disentanglement begins when we're trying to get them out of there, trying to free them from whatever is preventing them from leaving the trench. This phase can be quite manpower intensive. It may involve lots of shovels, buckets to remove soil physically from the trench up and out. Your focus, of course, is to remove soil from the head and the chest first. That's what's going to kill them. That's what's that's the issue. So remove and focus on the head and chest. Before you get too crazy and continue to shovel or otherwise remove soil, you need to consider the need for crush syndrome protocol, especially if they've been down there for a while, and likely they have. So paramedics, know your crush syndrome protocol. Make sure you're using deliberate and careful shovel strokes. You do want to be fast, you want to be swift. At the same time, we don't want to add additional traumatic injuries to our patients by gouging them in the face with a shovel. Do not attempt to pull the patient free until the rule of thumb you might hear is don't pull or tug on the patient until you can see the tops of his feet. Now that's just the saying. Likely they're not standing up vertically and you have to dig them down to their feet. Likely they're in various supine, recumbent, crushed positions. The point of the saying is, just don't start yanking and pulling on things that you can't see. It's possible that the patient has fractures because of kind of the splinting mechanism of the soil surrounding it. The patient doesn't feel it or can't feel it. The soil's cold. They don't know in what position their extremity is located. It could be snapped and broken and angled a certain way. You expose a knee and think that you're good to start pulling, and you cause additional trauma to the patient. So get that head and chest free, clear it up, reevaluate your situation, and then move forward accordingly. Soil's very heavy, and it will hold your patient in until you've done a good job of exposing them. When removing things like concrete pipes, all your extrication rules apply. All your lift an inch, crib an inch, that kind of thing, all that applies, so you still have to be mindful. You might have to get a little bit creative down in a trench to make it so you can lift the way you want to lift, but all your rules apply. You may consider stabling an object in place and keeping it from moving while you actually dig the patient free. Remove soil, stabilize the object, remove soil, remove soil, remove soil, till the patient actually is able to kind of lower himself out of it or free himself from that object. Aside from CRUSH syndrome protocol, keep your medical care fairly basic. You don't want to be too involved with that to the point that you are detracting from the rescue effort. Of course, it's all situation dependent. Use prudent judgment, as they say. Don't forget your option of a vacuum truck. Hopefully you practiced with it during the pre-incident phase of trench rescue, and you're familiar with it, and the operators are familiar with it. If you haven't practiced with them, then look into your local utilities groups and see who would come out. If you actually requested a vacuum truck through VEC, who's it going to be? Or touch base with your local city groups. Our local department in West Jordan. They're fantastic. We've had them come out many times and work with us. They enjoy coming out. From everything I've experienced, these vacuum truck employees, these guys that run these things on a daily basis, you give them an opportunity to come and do something different with it, and they love to come out. They love to train. They're great guys. They know their equipment better than we ever will. So call them, see if they'll come out, tell them what you want to do, explain why, and most times they're more than happy to come, and they're learning, you're learning, and it's great. And it's a great resource. You do need to know how to get a hold of it. Maybe you get a hold of a vacuum truck through VEC. Maybe you have a direct line to people you work with in your utilities departments that will answer the phone and can arrange that. And a lot of times that might even be faster than seeking a vacuum truck through other methods. Okay, but be familiar with it before the trench collapse occurs. Okay, we are almost through this. So the removal phase, obviously, once the patient has been disentangled, we're going to remove him. You can remove him various ways. So this phase begins from that point when we're actually starting to lift him from the trench. Again, I'm not going to get real detailed here. This is really something best explained on scene, on site. I wouldn't say on scene. That's a bad place to get familiar with it. On a training exercise, that's where you want to get familiar with this. After the slideshow, you can pause. Pause it, go out, and again, get your hands on your equipment. If you have a bipod, if you have a specific aerial device that you would use, go out and train with it. And make sure you know it. So obviously, you can remove a patient from a trench via the inclined plane principle, giving you that mechanical advantage, making it easier for you to pull the patient up. Spec pack is commonly used. You can use the Stokes. You can use the sked. Know your equipment, train with it. But the inclined plane method is simple. It works fairly well. You can set up a little rope system to help facilitate pulling the patient up and out. But additionally, as you saw earlier, you can use a Stokes basket for direct raising. That top right picture's got you. You got you seeing that. We also have a bipod. So there's other equipment. There's several types of equipment available in the valley for doing this type of removal. Just know it and practice with it. So the final phases here, rescue and recovery. So this begins after the patient is out of the trench and receiving his appropriate care. And now we have to recover our equipment from the trench. This is where lumber has a significant advantage. As with lumber, it's a total write-off. We walk away from this trench and we can leave our lumber in place or recover it at some other time later. Our Paratech, our expensive rescue equipment items like Paratech, like AirShore, relatively speaking, you want to recover those fairly quickly. Of course, between the patient removal phase and the recovery and termination phase, it's a good time to pull away from the trench, pull everybody out and away, hot wash if needed, talk about things, let people rehab, let people get, a little bit of rest, water, food. Just take a breather, look at something other than this trench. Of course, this phase ends when everybody's home and you're cleaning up your gear. Recovery and termination is dangerous because at this point, the excitement's gone. You've likely been on scene for quite a while. You're tired. You're exhausted. The patient now is out and hopefully safe, or out, and the body will go to the appropriate places that the body needs to go. But at this point, there's a real need to make sure that rescuers are mentally healthy, physically healthy, and able to continue this process. If you're going to recover any equipment from a collapse, when you're dealing with real soil, you've put a bunch of pressure into the soil already. You've stabilized it. The soil was stable. Somebody excavated. It was now unstable. It collapsed. We've come back in with our stuff. We've put it in a shoring system. We've stabilized it. There's been pressure in the soil. Now again, we take that pressure away as we try to retrieve our equipment, and there is certainly potential for collapse there. So conduct your your debriefings, your hot washes, your discussions that you need to have. Make sure just guys are fit and focused. You might need to replace guys, rotate jobs, etc. Make sure that the guys who are going into the trench to break this thing down are sharp and on the ball and mentally with it and focused. When recovering equipment, the order is reversed. So whatever was the last thing in, then becomes the first thing out. There might be times when you need to reinstall middle struts if you remove them. Once our equipment is recovered, then it's truly time to terminate the scene, get the command turned back over. Maybe a crime scene. OSHA, of course, may be there. Speaking of, with a true trench collapse, with bodies involved, with a victim involved, obviously OSHA will be on site. You want them on site, and you should not recover or remove anything from the trench until your OSHA officials have said, yes, you're good to do so. OSHA may have an investigation they want to do where they want your equipment left in place. So make sure you don't remove any equipment until it's deemed appropriate to do so. Again, rescuer health is big. More and more nowadays. Of course, as you know, we've been noticing and paying more attention to rescuer health. Trench collapses often involve close contact or prolonged contact with a body or with someone needing rescue. And whether they survive or not, there's a need in any situation where there's been a trench collapse to make sure your rescuers come out of that and receive the support and care that they need to be able to stay healthy and continue in their careers. All right, so let's do a knowledge check. Can you state the phases of trench rescue emergency response? what occurs during the pre-incident phase of trench rescue. I really don't think I need to read these. You can pause pause the video and look at these questions, and use these questions here as a knowledge check for yourself. Discuss them with your crew members, and use it for yourselves. If you have any questions, go back and review the slides. Okay, so if you want to pause it here, go ahead. And a handful more questions here for you. So certainly I don't know everything there is to know about trench rescue. I have a ton to learn. It's a subject matter that I love. I've been involved with it heavily since 2006. I think in West Jordan we certainly have an aggressive trench rescue program. I take a lot of pride in it. I do everything I can to make sure that every year we get several trenches to go out and to practice in, and always try to push our skill level and make sure that we're not getting too settled in just a mundane routine. But I certainly have a ton to learn myself, and so use this slideshow just as a means for prompting training, for prompting further discussion. Please now go out, make sure you understand things. You can review the other videos on the YouTube channel and see what they offer. There are a lot of individual skills that give our guys in West Jordan a format, a little easy thing to review, so they can hopefully stay sharp on their skills and be ready for testing when we test them. But use this slideshow as a springboard for discussion and examination of your own equipment and methods within your department. Here in the future, I'll be putting together a step-by-step example of T trenches and L trenches, so that you can learn T trench and L trench that way if you haven't already. But again, I'll close by saying a live, qualified, in-person instructor is really what you need to go out and do any of these things. Don't view any of these slides or individual skills or any of the things on this YouTube channel as don't view it as a sole source of learning, but just as a helpful way to review. For live instruction or live trench exercises, please get with a qualified instructor. We've got several good in the Valley and elsewhere, so please go out, have fun with trench rescue training, and be safe. Thanks.